Now we're going to get into more, as the unit's called, more derivatives. So we're going to get into more challenging derivatives. So the first lesson is on the chain rule. The chain rule is used to take derivatives of composite functions, meaning functions within functions. Does everybody see this is a composite function because it's a cubic function plus it's a linear function here, right? So in the past, the only way you knew how to find the derivative of this is to actually multiply it out and use the power rule. So let's do that. So expand using, actually, does anybody remember the binomial theorem? Because it would be faster if we knew the binomial theorem, but we don't remember it, so we're going to have to do. Okay, so the first thing we're going to do is do this FOIL. So what do we get there for that FOIL? 4x squared, outer and inner gives me plus 4x plus 1. So now I have to multiply that by 2x plus 1, yes? So now the only way we know how to do this is with a distributive property. So we're going to take 4x squared and multiply it by both of them. So we're going to get 8x cubed and plus 4x squared. Then the next one we're going to take 4x and multiply it by both. So 4x times 2x is 8x squared, and then plus 4x, and then we're going to take the 1 and multiply it by both, so 2x plus 1. So if I combine all of it, I get 8x cubed plus 12x squared plus 6x plus 1. So then we need to find the derivative of that, yes? So therefore, dy dx equals 24, yes, x squared plus 24x plus 6. Everybody good? Okay, so I'm going to show you why and how this chain rule works, okay? And then I'm going to show you a short little video that might make you laugh. But anyways. So the way the chain rule works is we're going to do the same question, except we're not going to multiply it out. We're going to break it into smaller parts. So we're going to actually pretend this is, not pretend, we're going to make it equal to u. So can anybody tell me what du dx is? Meaning the derivative of u with respect to x. It would be just 2, right? Well, because the derivative of 2x plus 1 is just 2, right? Okay, so if u is 2x plus 1 and I substitute u in there, y would then be u to the power 3. Does everybody see that? Okay, so then what would dy du, meaning the derivative of y with respect to u, be? 3u squared. Are we good so far? Okay, now we're going to actually put it all together because we're not trying to find dy du or du dx. We're trying to find dy dx. Okay, so in order to do this, what we're doing here is we're going to put them together. Do you see? And we're going to make these two into dy dx. So if I put du dx, this is a u by the way, not a dy. I'm going to write it again, sorry. Du dx times dy du. Do you see? I'm just taking those two and multiplying them together. Does everybody see the du's would cross cancel, and I'm really just calculating dy dx. So it's all legit. So what's du dx? 2. What's dy du? 3u squared. Does everybody see what I got? I'm just substituting for what that was. So you might say, well, but the original question had x's in, so the only next step we have to do is this is 2 times 3, 2x plus 1 to the power 2. And you might say, well, that's not the answer you got up there. Well, if I were to multiply, and you'd say it in that tone too, right? if I were to multiply this out, I would get that. So if I do the exponents first, just to prove to you it's the same exact answer, what do I get when I FOIL 2x plus 1? 4x squared plus 4x plus 1, yes? And what do I get when I multiply 2 times 3? 6. And what do I get when I multiply 6 times 4x squared? Look at that. I get the same thing as what I did over there. So this is why the chain rule works. It's basically I'm making with the composite functions I'm building something that's easier to do. But once you get what you're doing here, you don't have to actually do the du's and dx's. All you're doing here is you're saying whatever the inner function is, do the power rule. Do you see? So I get y prime equals, the 3 goes in front, and then whatever's inside stays inside to the power 2. See, that's this part, 3, whatever stays inside to the power 2. And then what did I get to get that extra 2? I found the derivative of the inside. That's what I did. Okay, so hold that thought. I'm going to show you this little video. Now that you know how the chain rule works, let's do this. So, do you see this would be really hard to multiply it out, right? So we have the inner function, the inner doll. We got the inside to the power 7. So when I find the derivative using the chain rule, it's going to be, that inside is going to be left alone, and we're going to use the power rule. Does everybody see that? Yes? And so then this is still x squared plus 5 in brackets. Okay? But then we had to do the additional thing for the chain rule to work, and that's to find the derivative of the inside, so then it would just be 2x. Done. That's it. But it gets more complicated than that. Okay. Are we done? Okay. That's it. We don't have to simplify that. Well, I guess we could, but that would be just crazy. That's the derivative. The only way you could, well, the way you could simplify this, actually it's a good question. I shouldn't say it. So we get 14x times x squared plus 5 to the power 6. That's how I would simplify it. That would be the only thing you would do. You wouldn't multiply the x squared plus 5 to the power 6. You want to take a second derivative, you're saying? Or what are you saying? Okay. Okay. Let's just relax here. Okay. So the way it works is if you have a function composed of another function, it is the derivative of the outside function leaving the inside alone. So you're taking the derivative out of the outside, leaving the inside alone, times the derivative of the inside function. So to apply the chain rule, here's the algorithm. If you get stuck, you can look at this. The main thing is to identify the inner and the outer function. Usually involves brackets. The brackets is the biggest thing that shows you the inside and the outside function. Take the derivative of the outer, leaving the inner alone, and multiply by the inner derivative. Bam, that's all you have to do. So this one's pretty easy because it has brackets, so it's pretty obvious what the inside function is. So dy dx then would be, Kyle? At this point, we should know how to do this. Dawson? 12 in front. And we're done? No. Then it's times the derivative of the inside, which is 2x plus 5. So then we would simplify as, I don't know if I would. I would just leave it like that. Yeah. Okay. The next one may be a little bit in disguise. Is it pretty obvious what the inside function would be? The x squared plus 9. But maybe you want to write it as y equals bracket x squared plus 9 to the power a half, just so it's pretty obvious the power rule. The square root is the power of a half, yes. Y prime then would be... Rachel, you want to tell me what the answer is? Times 2x. Okay, now this one we could actually simplify. So the 2x times the 1/2 would give us x. And then what would this be written as? Over the square root of x squared plus 9. Just in case that was a multiple choice, then I'm just making sure. No, you wouldn't square root that. You can't. No, you couldn't. No, you couldn't. It wouldn't. It would not. Because x squared plus 9 is not x plus 3 times x plus 3.
Can you leave it as the third one?
If it was find the answer and do not simplify, yes. But if it was a multiple choice, it's probably in this form. Yeah. Okay, next one. You guys want to try this one?
Yes.
Is it pretty obvious what the inside function is? Yes. Okay, I'll give you a moment to figure it out, and then we'll go over it. F prime of x, the derivative sign is cos of the same thing times the derivative of the inside, which would be 2x. And so I was just mentioning that we usually don't leave the 2x here. We usually put that in front. So 2x cos of x squared plus 5. And once you know that you're going to do that, you might automatically just put it in front like automatically. Okay, for this one though, does everybody understand there is an inside function here in disguise? No. This is the same thing as cos x to the power 3. Does everybody see that? Cos cubed x is not cos x cubed. We learned this in grade 12, right? It means the whole thing cubed. So remember that, right? Because there'll be a multiple choice that sways you into something with that cubic in another spot, right? So.
Can we leave this one as like this?
Probably, yeah. So does everybody see this is 3 cos x to the power 2 times the derivative of cos x would be minus sine x. Now watch, though, if you don't have a bracket and you put a minus there, it'll mean subtraction, so watch that. Honestly, this should be simplified pretty easy as minus 3 sine x cos squared x. Like, why don't you just take that extra little step and clean it up, right? And if you don't practice that enough, then when it comes down to the multiple choice, you won't see a lot of those things, right? Okay, how about this one? I'll give you a hint. This is a nesting doll of 3 dolls.
3 dolls.
3 dolls. This is a nesting doll of 3 dolls. Because you see, it's cos of 3x, but it's sine of the cos of 3x. So there's my layers now coming. Do you see that? So the question is, and I use this analogy. Do you remember how he took apart those nesting dolls? It's the biggest first going into the little. So remember that. That was the point of the video. It's the bigger doll going into the little. So it's the bigger function going into the smaller one. So what am I finding first? So I'm finding the derivative of what? Sine x. So what's the derivative of sine x? Cos of the thing inside left alone. So that would be cos of 3x. Does everybody see that? Multiply. Remember, this is all multiply, and some of you are going to get wrong with your brackets here and stuff. Now we're going to take the derivative of cos of 3x. So what's the derivative of cos of 3x?
Negative sine of 3x.
Minus sine of 3x. Then we have to take the derivative of that inside, which would be then times 3.
You probably want bigger brackets.
I probably need to have, yeah, bigger brackets around the whole thing for sure. So I think I want to put this whole thing in front just to simplify it a little bit, clean it up. So minus 3 sine 3x cos of cos 3x, like that as my final answer. Okay, so the first thing I would do for the next one is rewrite the square root as to the power 1/2. Everybody understand that?
Brackets.
So the biggest problem then is there's so many brackets. You got to really keep track of it. So in the age of technology, I use the first is this whole blob. Does everybody see? It's the derivative of basically the blob. So what would that be then? So f prime of x is 1/2 the blob to the power negative 1/2. So we're not going to write the blob. We're going to get rid of this. Ooh, I'm going to get rid of this blob and put this back in. And so this is going to be 2x plus bracket 3x plus 4x squared to the power 3. So then, now I'm going to use a different color pen. I have to do the derivative of this inside, right? Now the inside has lots going on there. The derivative of the inside, this is easy, right? But this is another chain rule. Do you see that? Yeah, so what's the derivative of 2x? 2. Now we need to do the derivative of this, but this is a chain rule. So plus
3.
So yeah, so it's going to be 3, leave it alone, 3x plus 4x squared to the power 2. Now I have to multiply that by the inside, which is 3 plus 8x. Bracket. You got to close the bracket. That's this one here, right? And that's it. Yeah. It's this whole darn thing here. Do you see at this point you're not going to be simplifying anything at all?
Never.
So this next one is just for all you keeners. This is just craziness. I highly doubt that they would ever ask you this hard. By the way, this should be a t here, so fix that up before you go further, because you're actually finding the derivative with respect to t. So, well, we could make it all x's if you want. It doesn't really matter. You like the x's better? I can change it all to x's, because okay. Okay, so what is the outside term? I'm going to actually write this because there is a 3 there that might get people screwed up at the very get-go. So it's sine of 3x squared to the power 1/3 plus 3 sine 6x bracket. So that's that. There's an extra bracket in there, by the way, to the power 3. Okay.
It's to the third, not to the half.
Oh, to the third, yes. Okay, thank you. Okay. Okay, I haven't found the derivative yet. I'm just rewriting it, okay? So g prime of x equals 3 of this whole thing. So sine of bracket 3x squared to the power 1/3 plus 3 sine of 6x bracket bracket to the power 2. So I just did the outside power, which was a power rule to the power 3, so it's now 3 blob to the power 2. So now I'm going to do the inside function. The inside function is sine now, right? So it's going to be now cos of the inside function. I'm going to do the inside function so that it's red so you can see it a little bit better. The inside function is this part, right? So it's going to be cos of 3x squared to the power 1/3 plus 3 sine 6x. Bracket. Okay, so then now I need to find the derivative of this inside. Does everybody see what I'm doing? This is where I'm going to go to the next line. So the derivative of 3x squared to the power 1/3 is a chain rule. Do you see that? So it's 1/3 3x squared to the power negative 2/3 times the derivative of this, which is 6x, bracket, plus, this is a chain rule as well. So there's the chain right there. So it's going to be 3, the derivative of sine is cos of 6x, and then you have to times it by that, which would be another 6. So you can make this an 18 if you wanted then. Bam!